Alright, hey guys, in this video I want us to look at how to simplify the complex fractions. There's two methods that we're going to look at. One is multiplying by the reciprocal, and then one is multiplying by the LCD. And then we'll look at maybe in which situation it might be best to use one versus the other. Alright, in this method, in this example, we have 12 divided by x minus 4 divided by 3 over x. And so anytime you have one simple fraction being divided by one simple fraction, I recommend the multiplying by the reciprocal method, which, again, think about how we divide fractions. We keep, change, flip. Okay, remember, when you divide fractions, you keep, change, flip. So that says I'm going to keep the first fraction the way it is, so 12 over x minus 4. We're going to change that division to multiplication, and I'm going to flip that bottom fraction. So instead of 3 over x, it becomes x over 3. Now I can simplify the 12 over 3, the 12 into 3, so divide each one by 3, we get 1 and 4. And now we're ready to multiply. So on top I have 4 times x, which is 4x. On the bottom I just have x minus 4 times 1, which is just x minus 4. And there's my simplified version of my complex fraction. Alright, let's look at another one here. Okay, here we have 1 over z plus 9 divided by 1 over z minus 6. And so, in this case, notice we don't have just one simple fraction on top and one simple fraction on the bottom. We have a complex fraction in my numerator, complex fraction in my denominator. And so in this case, I want to multiply by the LCD. And so if I look at all my denominators, my LCD would just be z. And so what I want to do is I want to take that z and I want to multiply it by each term individually. What this is going to do is cancel out some of those fractions. So here, z's cancel, leaves me with just 1. 9 times z is 9z. On the bottom, again, z's cancel, leaves me with 1. And then 6 times z is just 6z. And there's my simplified fraction. Again, there's nothing else we can do there. Alright, again, I notice I have a complex fraction in my numerator, complex fraction in my denominator, so the LCD method. So my LCD in this case is x times y. Okay. So we're going to take each term and we're going to multiply it by this x times y. Okay, you got to make sure we do it to each term. Alright, so now xy times 7 over y, well the y's cancel, and so we get x times 7, which is 7x. Plus, on the second one, the x's cancel, and so we get 7y. And on the bottom, more y's cancel, so I have again 7x. And then x's cancel, so minus 7y. Okay. Now on the top, I can factor out a 7, and that's going to give me 7 times x plus y. On the bottom, I can factor out a 7. That's going to give me 7 times x minus y. Now my 7's will cancel, and we're left with x plus y divided by x minus y. And again, that is our final answer. Alright, let's look at one more. Again, we notice that we do have one simple fraction on top, one fraction on the bottom, and so I am going to use that keep, change, flip method, which says we want to keep the top fraction the way it is, so 6x minus 12y over 14. Now we're going to change that division to multiplication, and I'm going to flip that second fraction, so x minus 2y. Alright, now we got to make sure all my numerators and denominators are factored completely. So on this first one, I can factor out a 2, and that's going to leave me with 2 times. Actually, we can do a little bit better. We can factor out a 6. And so if we factor out a 6, that's going to leave me with x minus 2y over 14 times 7x over x minus 2y. Alright, so what we see now is the x minus 2y's cancel. 7 becomes 1, 14 becomes 2. And so we get 6 times x on top, which is 6x. And then we get 2 times 1 on the bottom, which is just 2. And now 6 over 2, we can simplify that a little further, and that gives me a total of 3x.